ladies and gentlemen.
Today we're going to be solving some problems that involve us having to know multiple forms of quadratics and how to move in between them, specifically more along the lines of factored form and standard form. So let's get started. So the first one here is if a and c are constants and x squared plus ax plus 5 is equivalent to x plus 1 times x plus c, what is the value of a plus c? Well, there's a few things that already spark in my mind. First and foremost, to get this term here, when I distribute this factored form here, that term, that 5, is going to happen when I do 1 times c. So 5 is equal to 1 times c, which is really easy to see that c is 5. The a is a little bit more complicated. The a term is going to occur when I distribute x to c and 1 to x. So ax is essentially the same as 1x plus cx, which means that ax is equal to 1 plus c times x, or that a is equal to 1 plus c. So if a is equal to 1 plus c, then a has to be 6, which makes sense because if I have the quadratic x squared plus 6x plus 5, this is the only quadratic that would factor to be x plus 1 times x plus 5. And it's the only one that gets me that x plus 1 specifically. So there we go. As far as the question goes, what is the value of a plus c? Well, 6 plus 5 is 11. Here's another interesting question. So it says if x plus 3 is a factor of x squared plus 2hx plus h squared, where h is a constant, what is the value of h? Well, if I look at this form here, the only way for me to really factor this out would be to separate this a little bit. So if I go x squared plus hx plus hx plus h squared, I can factor this to get x plus h plus h, x plus h, giving me x plus h times x plus h, or x plus h squared. Now, if you recall from one of the prior videos, one of our special factors or factoring techniques is if I see this is 2 times the square root of this, which is h, then I know that this is going to factor into a square. So if x plus 3 is a factor of this, and all the factors are squares, what is the value of h? Well, h has to be 3. The only way for this to work is for this to be x plus 3 squared. There we go. The last one, a little bit interesting. The following equation is true for all values of x. If c is a constant, what is the value of c? So we're saying that we have a cubic is equal to a quadratic times a linear, makes sense there, and that we have this factor of x minus 5. So what I'm going to do is I'm going to factor out this x minus 5 from the cubic. How am I going to do that? I'm going to do that through synthetic division. I'm going to say that this is a 5. If I solve this for x, it only works for 5. If I set it equal to 0, 5 goes in my little box. 1, negative 6, 8, negative 15. And we go about this as we normally would. We drop down the 1. 1 times 5 is 5. Add those, you get negative 1. Times 5 is negative 5. Add those, you get 3. Times 5 is 15. Add those, you get 0. We can see that it is a factor. We have no remainder, which means that we have x squared minus 1x plus 3. What is c? Well, c is negative 1. So not too bad. You really just have to be able to be comfortable working between standard and factored form. Remember that there are special ones. We have x plus a times x minus a. It's the difference of squares. That's x squared minus a squared. We also have x plus a squared, which turns into x squared plus 2ax plus a squared. And if you have those, it helps out with some of them, but you also just have to be comfortable factoring and distributing and dividing polynomials. So if you have all of those skills down, you'll be able to solve problems like this. So good luck with your practice, and I'll see you in the next video.